This is the video supplement for the paper RL-PGO. In this work, we present the first deep reinforcement learning model to learn a policy that predicts the optimal orientation retractions from pose graph observations. The agent can be utilized to search and explore the initial pose trajectory configurations with the goal of returning the optimal or ground truth trajectory by learning through interaction with no ground truth labels. The proposed modular encoder agent architecture is comprised of two main components. The first component is an encoder used to capture the observed orientation cost of the graph, and the second component is a recurrent soft-actor critic agent whose policy predicts the optimal orientation retractions. The video on the top left depicts an agent training on a small pose graph environment randomly sampled from an assigned environmental noise distribution every episode. We see the agent cycling through every edge in the red simulated noisy pose graph and applying retractions to the orientation components of each neighboring pose. The image on the right illustrates the cumulative reward plot after 1,000 episodes of training. The agents are then evaluated on synthetic and real-world graphs much larger in size and unseen during training to demonstrate generalizability. Reinforced learning agents trained on smaller toy pose graph environments with no ground truth labels were able to generalize well to graphs with dissimilar noise distributions and odometric trajectories at test time. These tables indicate the performance comparisons amongst the proposed approach and Limerick-Marquardt solvers implemented on G2O and GTSAM set to run until convergence. It can be observed in Table 2 that standalone reinforced learning outperforms GTSAM's Limerick-Marquardt solver on challenging instances with very poor initial guesses where traditional gradient-based solvers fail to decrease the observed cost. Thank you for listening.